I welcome all of you to this course, Fundamentals of Combustion. A question might be coming to your mind, why combustion is important? Maybe another question will be lurking in your mind, what is combustion? Is it relevant today or it is a very old subject? If you look at it, is an old subject, right? And when really this combustion, as a science and its application started, a lot of question might be coming to your mind. How it is relevant to your curriculum or your, these things, whether it is relevant to life or not. So, some of the question might be coming to your mind. Is it really coming? See, if questions are not coming, then then you cannot learn, because question can never be a silly, it can be a beautiful lily in the garden of knowledge, that is the truth as after age, right. So, therefore, you must encourage the questions to come up in your mind, that is the first step, and next step would be to explore it, to get answer for these things. So, if you look at combustion is as old as civilization, human civilization. Civilization means human civilization, right? You are aware of how many civilizations were there in this beautiful planet and which are very great. Any idea? No, right? Roman civilization. What else? Indus Valley civilization, Mesopotamia civilization, Greek civilization, right? But if you look at all these civilizations today are still alive, they are dead except one civilization. What is that? What is that civilization? Except one civilization, you won't get the signature of the civilization in that country. For example, if I go to Rome, can I get that? About whatever it was happening, let's say 5,000 years back or 6,000 years back, but there is a one civilization which is having that legacy. Those signatures are still alive. What is that? Any idea? Huh? Certainly no. It is only Indian civilization which is still alive, but it is about to die due to cultural invasion, right? Are you getting my point? And what was the turning point for the civilization to prosper? Human civilization, people were living in jungles, right? What was that? Huh?
Discovery of fire.
Discovery of fire. So therefore, fire is one of the greatest discovery of mankind. And if you look at, if you go to our Vedas, if you go to our scriptures, what it says? What the scriptures say? Agni Deva Bhava. Agni means fire, right? If you take bath in our culture, if a baby will take bath, then what? We will welcome with a lamp, diya, jala ke, welcome करते हैं. जब मर जाता है आदमी, क्या करते हैं? जला देते हैं, right? We incinerate it, and that's why. And also in between, a lot of our rituals are having lamp, with a lamp always. Am I right? So that's because we always remember fire is important for life. It is the external fire, also the internal fire. So fire is one of the greatest discovery of mankind, and you should people might have learned how to make a fire, set a fire, but it is important to also set in a proper control manner. So control is important. So if you look at man's subsequent mastery over the fire, and has culminated into all the developments what we see. If you go to our Vedas, there is a yajnas, the people who are saying that they were, these are all not yajnas only, they were knowing how to manufacture the material, how to process the material, how to manufacture the products, they claim. Why I am saying this thing, I had done one course, Ancient Indian Technology. You can see in there in the YouTube as a part of MOOC course. The plethora of knowledge was there in our country, but those are, all extinct, unfortunately. So that was the genesis is the fire, has made all the development in science and technology that we enjoy today, right? There is nothing wrong in enjoying the fruits of the science and technology, but we are abusing it, misusing it. As a result, what is happening? Instead of developing, instead of moving on the path of development, what we are doing? We are on the path of destruction. What people are calling it as development, this is not development. So therefore, also the combustion plays an important role in the sense it is should be used for the boon, not as a bane. But unfortunately, it has been not being used, and we are part of this present days, and we are responsible for it. So most of the modern technology development have emanated basically from the discovery of fire. And as a result, what will happen? We have all materialistically developed, you can say, and we are what you call spoiling the mother earth resources, and there is a segregation of the wealth, right? You might be aware. We should aware about that thing, and this is related to the combustion to tangentially, little remotely, but you must understand that it is important. As a result, that modern civilization is basically built on the combustion of fuels, both for the heat and electrical power. What you see today in electricity, you can see these computers, you can see all those things. Electricity is very important, isn't it? So also, like for your heating purposes and all process industries, and keep in mind that as a result, there is a what you call problems of emission, right? Pollutions, emissions from the various combustion devices plays a major role for the air pollution. Do you think that it also affects the water pollution? Yes or no? It does, because in power plants and other things, you will have to also spoil the water. So water pollution, air pollution, and also the soil being polluted, and we are all in deep trouble. So when you talk about that, there is always hampering the development what we are having. We are a which country today? We are a developed country, a developing country, or underdeveloped country? We are developing country, right? See, at the parlance of the terminology used by the Western people, right? But is it development? According to me, it is destruction. Okay, are you getting? But even if we accept that, that means if you want to develop, we will have to use more energy. That is the thumb rule, but that is not the case. That is the what they are talking about it. Then we will do that. That means we will use more fuel, more emissions we will be making. We will make that. Then they are putting a pressure on us that you should change your system so that emission will be minimized. Otherwise, you will have to pay price for that. Carbon footprints and then credits. Carbon credits, all those nonsense things they are doing. Why they are doing? Because they want to. They have spoiled the world. Now they are saying you don't do that. Are you getting? So now is a challenge. For that, we need to study the combustion, because knowledge of combustion is very relevant today what it was, let us say 100 or 200 years back. So as there is a stringent rules, global rules, like international arena coming up, and which we will have to follow, otherwise they will twist our arm. How they will twist our arm? Why they will twist our arm? Because we are depending on them, we are not independent. Although India got independence in 1947. Are we independent? Are you independent? Are we independent? No, we are day by day getting dependent on them. So therefore, now it is a vicious circle. How we will come out of it? God only knows, right? Of course, I am having a plan for that, but that I will not discuss in this course, okay. So that, but even if you want to follow the whatever it is going on, the way of development, we cannot do it because the stringent emission rules are coming, and which we will have to redesign our combustion systems and other related systems such that we will go ahead in spite of their stringent rules and regulation. And also there is a scarcity of fuel. Fuel is precious, okay, am I right? So therefore, we will have to minimize the utilization of fuel, rather in other words, you will have to enhance the efficiency of the systems, means combustion efficiency, thermal efficiency, other things, right, and even emission, minimize the emissions. So that is the need. Therefore, we need to look at the fundamentals of combustion so that we can know how to tinker, how to understand the process so that we can develop better engineering combustion systems. So that is the main motivation why we should re-look at and look at the fundamentals. Question is, what is combustion? Can anybody tell me? What you are all aware of these things, right? So okay, that means burning of fuel. Now question might be arising, what is fuel, right? But in a common man language, you can say that, you can say setting fire to the fuel, right? And when you say that setting fire to the fuel, and that must be in a controlled manner, right? If it is uncontrolled, what will happen, right? It will lead to destruction, right? If you look at the fire I have shown here, can anybody guess this fire is having particular shape? Can anybody guess this fire we do once in a year? What is this fire? And around this thing people will be moving around in the night. What is this fire related to? Holika fire, right? And it is related to our culture, okay. I will not get into detail why you will celebrate that. We are having enough things to celebrate than that of celebrating your birthday, Valentine's Day and blah blah blah, which is coming from the outside and they do not fit into our cultural milieu. We should resist those things because those are not our culture. So therefore, this fire is important, it should be controlled, right? And so when you say this thing, then what is really happening? That means there is in the combustion is taking place means what? There will be heat. If you go, and this is generally occur in the winter, you will go and take the heat, enjoy the heat, right? Okay, that means heat will be produced by the combustion, yes or no? And you could see also, can you not see it? Colorful, right? And then you see means, that means during the combustion heat will be generated, so also light. How does it taking place? It is basically a chemical reaction in which fuel is burnt in presence of oxidizer producing heat and light, right? Heat is there and light is there. When you talk about heat, that means what kind of chemical reaction will be taking place? Is it there any reaction which will be endothermic or not? There is a two kinds of reaction so far the heat is concerned. One is exothermic, other is endothermic. In exothermic, the heat will be liberated. In endothermic, you will have to provide heat or it will be consumed, So is there any exothermic reaction will be taking place or not? Huh? There might be, but overall effect will be exothermic, right? Is that clear? So that means combustion is a process, also self-sustained chemical process. In other words, combustion is a self-sustained chemical process in which heat is liberated due to overall exothermic chemical reaction. right. Overall, you can sum it up as a single reaction, then you say it will be exothermic in nature. And it is not that simple that like only single reaction will be going on. It is a complex sequence of chemical reaction between fuel and oxidizer, accompanied by liberation of heat and light. There will be heat and there will be also light. There might be some combustion in which the heat is being liberated all the time, right? Is there any combustion where heat won't be liberated? Certainly no, right? But however, there is some type of combustion in which you won't see the light, right? Any idea about that? What kind of combustion it would be? And what gives it light? That also a question might be coming to your mind. Why I could see, right? But you might have done some experiment in your chemistry class, right, where the reaction will be taking place, but you won't be knowing, right? You can't see even. Am I right? Even if you are doing a reaction test tube, you won't see. Am I right? But there is no light as such. There is some chemical. You may feel it is hot, right? Isn't it? If it is hot, means it will be exothermic overall. So, will you call it a combustion? That is the question. That any chemical reaction need not to be a combustion process, right? So, what are the examples of combustion you have encountered during your lifetime? Any idea?
While cooking food.
Cooking food. What kind of cooking food means what, like
LPG.
LPG burners. You have seen LPG burner? How many of you people have seen LPG burner? All of you have seen. Okay, very good. So, what about any other things? Candle flame. You people are fond of candlelight dinner, right? Yes or no? Right? No. How come? It is a modern day candlelight dinner in restaurant. Go, like you won't eat food if there is a, let's say snap of lighting systems, right? Or the electricity has gone off. You won't take food late. You will wait till the light comes. But you will go to restaurant, pay money, and then celebrate candlelight dinner. In your home, you won't. Right? And what else? Other examples?
Internal combustion engines.
Internal combustion engines, right? What are those examples? Internal combustion engine means what?
Diesel engines, petrol.
Diesel engines, petrol engine. What else? What else?
Gas turbine.
Huh?
Gas turbine.
Gas?
Turbine.
Gas turbine engine. Is it an internal engine? Combustion engine? External. Is it internal or external? How many of you are saying external? 1, 2, 3, 4. How many of you are internal combustion engine? Gas turbine engine. Aerospace people, you have studied. Okay. I think some of you I have taught you, right? No, propulsion I didn't teach. Okay, fine. All right. But actually it is internal combustion, let me tell you. It is not external combustion engine. Okay, fine. Now, what else? Other things? What else? Baba, rocket engine, you aerospace people are there, you should tell me, I think some of you I taught in the last, semester. What else? What else? Furnace, like lot of other stuff. You have looked at fireworks, right? Those are also combustion. So, there is a lot of application you could see. We will be discussing more about it. But let us look at what are the essential conditions for combustion to occur. As you have already told, fuel is essential. Yes or no? Without fuel, there won't be any combustion. So, when fuel is there, therefore, the oxidizer will be there. It's like, if you look at life, right, is having a one component is male, other is component female. It is like a head and tail of a coin, but we do quarrel, isn't it? Like that fuel and oxidizer, can they quarrel? They will be part of the combustion. They cannot be, combustion cannot take place without any one of them. That means both are essential. If the fuel and oxidizers are there, then the combustion can take place. Is it possible? For example, in this room, I will feel the LPG gas and air is already there. So therefore, combustion will occur. That means I need to have ignition, right? Ignition, ignite. That, and that is known as basically what you call combustion triangle. That is fuel, oxidizer and ignition energy, because to initiate the flame you are having. But can you relate this to the life? Because always if you look at our scriptures, of course most of you might have not aware about what Indian scriptures were. You might be aware, na? Like Indians were having lot of scriptures which are destroyed due to invasion. Am I right? You are aware?
Yes.
Right? But still whatever the sting left over, it is plethora, it is too much to read it, but most of you are not aware. Anyway, I will not get into that, but I would encourage you people to look at it. They are more scientific than the what science we are talking about. So life, if you look at, it is the body, right, and mind and the spirit. Are you getting? Without spirit, spirit means what we call Atman, Atma, right? That if body is there, will it work? It won't work. If it is mind is there, will it work? It's useless. So is it related? Right. And once you have taken bath, you are getting consumed. Your life is getting receded, right? So similarly, life is that if fuel is there, it will be getting burnt. Oxidized there and it is ignition is there, then it will be getting consumed. So therefore, I have related to that. You can see this is life triangle. Now, even if fuel is there, oxidizer is there, ignition energy is there, is it combustion will take place? Suppose for in this room there is enough oxidizer is there, air is basically an oxidizer. Okay. What is the constituent of air? Any idea? 21% what? Oxygen. What else?
78% nitrogen and 1% other gases like carbon dioxide and other.
What else others? Water. Very good. Argon, right? Okay. But generally we assume it to be 79% nitrogen, 21% oxygen. Okay. But the rest of the things are very less. So that means air is basically one of the oxidizers. Let us say in this big room, I will put maybe 1 gram of LPG, okay, and air, let us say it is having 10 grams, okay. Will it, and I will give enough ignition energy, whether combustion will take place or not?
It depends.
Depends on what? It is mixed properly. I am having fan here, I will make it to mix, okay, it's mixed.
Temperature to cross reaction barrier.
That means I will give enough ignition energy, so that it will reach temperature, okay. Will it ignite? Will it, even if ignite, will it combustion will be self-sustainable? There is a lot of questions are coming, am I right? So what is that? It depends, that you told, na? Like can you tell me like what is that? That means the fuel air ratio will be proper. What you call, there is a limit between which it will work. It is mixed properly, it should be mixed, otherwise it won't work, okay. Now what you call that? And that is basically known as flammability limit. So we will be looking at little later on, but essential condition are presence of fuel, and presence of oxidizer, not essentially oxygen, okay, and they must be in the right proportion, ratio must be proper, and this proportion, the fuel air ratio or air fuel ratio, whatever you call, it should be within certain limit, right, certain range in which the combustion can take place, and that is known as flammability limit. And there is also ignition limit, right, because if you give very little ignition energy, then it won't, right. So, therefore, there is also known as minimum ignition energy. All those things we will be discussing little later on, much later, the course. So, therefore, these are the essential conditions for the combustion to be self sufficient, to propagate and then move. I will stop over here. Thank you very much.